All right, this is 2018 from number one. Okay, graphing calculator will be required. Okay,
Mm.
the first questions. I remember right, every first questions they always give a rate. Okay, this is rate is a kind of first derivative. Okay, yeah, that's the rate of change. Okay, not original graph. Maybe there is original graph looks like this one RT, right? So RT prime is a little t. This is actually what is that? Derivative, right? Okay, that's the
Mm.
rate. Okay, people enter a line for an escalator at a rate modeled by the function r given by this one. Okay, thus the rate means what? The people per second over here. Okay, that's what they use this rate, the unit of it. Okay, people per second. Every time that is instant. Okay, every time, sometimes t. Okay, uh, this RT is what enter the line. Okay, how many people get into the right escalator? Okay, but maybe you can use this escalator wrong when you go to airport. Okay, this is escalator over here, right? Just move. Okay, so getting inside people over here. Okay, so
Mm.
every instant, every times, how many people is getting in there? That is RT, little RT. Okay, I'm this. Okay, this is the rate. So, and out of this escalator, every time swap 0.7 people is out. Is okay. So I put in the white graph already over here. Okay, that is RT graph. Take a look over here. RT graph. Getting into escalator every times. For example, this one is, let me see what is it. Okay, this point. At time t equal 3.3, all right, at time equal what, 39.3, only one people getting in the line, okay? Are you okay, sir? 0.99 is what? Approximately one people get in the escalator, okay? Highest
Mm.
point of here, this is the highest point. At this time is what? When time t is 90 seconds, okay? In 90 seconds from the beginning, at this time, the maximum number is 2.6 people, right? 2.6 people got into escalator, okay? So after this, getting down, okay? Not many people already getting down all the way over here up to 300. 270 still zero, but not close to zero, right? That is a approximate number, okay? After 300, now finally zero. Nobody got into escalator. That's it,
Mm.
okay? All right. So the integral of this curve, right? It should be what? Total number of people who used what? Escalator, right? Are you okay with this?
Mm.
It's okay? All
Yeah.
right, now take a look over here. How many people enter the line? The question over here, how many people enter the line? Okay? Not how many people exit, just like enter the line escalator during the time 0 to 300. So we're gonna find, okay, all the people, right, on this rate. So 0 to 300, right? Okay,
Mm.
that is the rate. Under the curve, that is the number of total people. So we're gonna write down 44 times t over 100, and the cube, I'm gonna use RT, right? Okay, you can use RT, but I'm gonna write down this t over 307. That is RT dt, right? When you
Mm.
take integral, right, from 0 to 300, this rate is gonna be sum of all number of people enter the line of escalator. Okay. So now let's find this one first. I'm gonna use the decimals. Okay. So now people is integral. Oh, I did the integral. Okay. Here. I'm gonna put up here integral, okay? This is the integral. During the time first was 300 seconds, okay? The 0 to 300 seconds, the sum of all people over here. Put this number in here. After that, dt, okay, that work, okay? dt is what integral or 0 to 300, the total number of people is 270 people. Are you okay with this?
Yeah.
So this one is 270 people. Not per second, okay? Total number of people. All right, during the time interval 0 to 300, there are always people in line for escalator, right? Yeah, there are some people, right? Okay. How many people are in at time t equals 300? Okay. So at time t equals 300, how many people are there? Can you find over here? At time 300. So at the beginning, at time t equals 0, escalator, there are what, 20 people there, okay?
Yeah.
So after this, total is 270 people got into the right escalator. That's right? You already got over here 270. It was before 220, 270 people up to 300 seconds, okay? Up to 300 seconds. But every second, 0.9 persons out. It's okay? So every second is a 0.7 person, but this will be 300 seconds, right? It was being 300 seconds over here. Okay? This is the initial. And this one is during the 300 seconds, total 270 got into over here. It was 20 over here. We're going to check right at 300 seconds, okay? It was before 20 over here. And they got into the 270 during 300 seconds, but minus this number of people out, 210 is out. It's okay? But still, how many people in the line over here? 20 plus 270 is 290 minus 210 is still in the escalator. There are 80 people there. Are you okay with this? Is this understandable? This is escalator, right? At time t equals there are 20 people. During 300, 270 people got into the line over here, right? So now how much? 290. But during 300 seconds, every second, 0.7 people is out. 0.7 and times it be 300. So 200 people is out of the escalator, okay? So how many people still in the line of escalator? 290 minus 210, right? So that's why we got the number 80. Are you okay with this? I cannot hear you. Maybe your something wrong with your audio system. Can you hear me now?
Yeah.
Okay. So number A is okay, right? Number B, how was the number B? It's okay?
Yeah.
Right. But you have to understand what the question is, okay? Right, after 300 seconds, okay, after 300 seconds, was it first time t there were no people in the line of escalator? What is the first time t no people in the escalator? 0, right?
Yeah.
You have to solve this one, 0. It's okay? After 300. After 300, in 300, still there are about 80 people in the escalator. This escalator. Moving over here. After t equals 300, still there are about 80 people in the line over here, right? Are you okay with this? Okay, now for what is the first time, all right, no people in the line there. Nobody came in there. Zero. But zero point 0.7 people per second will be out of this escalator, okay? But it takes time for the all 80 people, okay, leaving this escalator. But only 7.7 people every second out. So total number is how much? 80 over 0.7, right?
Yeah.
So this is how much? 80. Let's find out. Eighty divide 0.7, okay? Every second, 0.7 people out. It takes what? 114 times 286. They didn't say anything number of decimal. Okay, they didn't say we have to already 3 decimal place over here, okay? 114 286. So 114 286. It takes this much every after 300 seconds. Okay? So we're gonna find by count the number of t from the beginning, right? So from the beginning, 300 after this it takes what 114.286 second again. Total how much? 414 point
Yeah.
at this time seconds. Okay?
Mm.
Then nobody in the what line of escalator, okay? Alright. But you have to add 300, okay? Don't forget this one, okay? For the first time, t is what from counted from 0, okay? Not after 300, right? After 300, it takes what 14.286 seconds. So from beginning, we're gonna count all of this sum of our time, okay? So we have to add these two.
Okay.
For number D, t is between 0 and 300. At what time t is the number of people in line minimum? The line minimum over here. To the nearest whole number, find the number of people in line at these times. How can you find the real over here? So actually, the number of people in the line, so you're gonna check, okay? You're gonna count over here. You're gonna find the number of people in line. It's okay?
Yeah.
So some people are getting in there and some other one is out. At the beginning, it was 20 over here. So total number is 20 plus. So from 0 to times t over here, right? Okay, at time t, right? Okay, t is a now variable. Okay, so rt is what 44 and times t over 100 over 3 and 1 minus t over 300 and 7 dt, right? That is what total number of people who got into what line of escalator in time t, right? We're gonna find the minimum value over here. After that, how many people out? Okay, we count out. How many people out? 0.7 times t, isn't it?
Mm.
Yeah, this is the number of people, right?
Mm-hmm.
Okay, using this one, you can use this graph, okay, and find out what the answer, okay?
Yeah.
Okay. Now let's find out the minimum value of this one, okay? Maybe I can show you the graph of this one, okay? Just give me 1 minute. Where is the graph? I cannot move over here, okay. I'm going to take this out. maybe I can, I don't know, it's a possible to graph of this one, okay? I'm going to take the, anyway, the number of people is y. I'm going to take this as y equals 20 is original in there, and the integral all of this one, okay? Or take this graph over here. But it's going to be, this is a time t, right? Time t, this is important, okay? And we're going to find the times t over here, the minimum value. After this, dt, and the minus, okay? 0.7 times t again, it's okay? 0. Times t again.
Yeah.
They give us graph over here. Oh, they don't give a graph. No. Okay, this one doesn't recognize the equation over here, okay? Okay, that's fine. Okay, anyway, we're gonna find, okay, maximum over here, okay? Now let's find out y prime, okay, dy dt, okay? We're gonna find the graph of these equations, okay? First one, you're gonna find the dy dt. Take a derivative over here, t equals what? 0. Okay, dy dt, but this t, you don't have to change this inside the, okay, variable, right? Just put this number t into t again. After you got this one, 44 times t over 100 cube, 1 minus t over 307. After that's 0.7. Are you okay with this?
Yeah.
This is what? The prime, that's the rate. We already got the graph of this one, okay? Can you take it over here? We already got the graph of this one, R over here, okay? Over here, we take what? 0.7, okay? 0.7, okay?
Yeah.
So we're gonna make a graph of it. This is the graph. It's okay? Yeah, this is the graph. For what value of t, okay, the number of people in the line is minimum. Okay. This is decreasing, right?
Yeah.
This is increasing because this is what kind of a derivative, right? This is decreasing in the line of escalator, right? Decreasing. This is increasing. It's okay. So at this time is a minimum value over here, right? At time t equal 33, that is minimum. Are you okay with this?
Wait, where is that?
Yeah, at this time t, that is decreasing, increasing. At this time, it's a local minimum, right? Can you do that?
Okay.
This is a positive. This is rate, okay? Derivative is positive, increasing and decreasing. At this point is what is the 166 point?
Okay.
5 to 7. At this times, it had what? Increase, decrease, maximum, okay? So we consider over this point, okay? At this point, it has a local minimum, okay? Right. But this one is also minus. Okay, I'm going to show you the graph of this, okay? This is the dy dt, the graph looks like this way. Here and here and here and here, right? 300. This point is what? T2 equal, this one T2, right? At this point is 1.166 and 575. This time is what? 33.1013. Okay? That is decreasing, increasing, decreasing. What is the graph over here? It was before that 20 over here, right? At the beginning, right? 20 up to here, that is decreasing over here. Are you okay with this?
Yeah.
But decreasing, what is that? Slope is positive, right? concave up, decrease. It's okay?
Yeah.
After this, that is increasing, right? Increasing is what? Slope is still positive. Slope concave up increasing. This is increasing. It's okay? But at this point is what? Point of inflection. Point of inflection still increasing over here, okay? After this point of inflection increasing this way. Are you okay with this?
Yeah.
And the next one is all the way decreasing, right? There's a concave down decreasing, all the way decreasing over here. So this is the minimum point. This is also minimum point. Or other one is to grade these 2 points. But we just check out the last point at x equals t equals 300. It is 80, right? It's okay? It is 80 at time t equals 20. That's right? 30, right? It is 80. So this graph looks like this way. Actually, I'm going to make a graph, correct graph of this one. This one, okay? This is 80 over here. But we're going to check this point over here, okay? At time t equals, what is that? T equals 33, only 1.3. How many number of people there? We're going to check it out, okay? This one is, we need via calculator. Y equals number of people, what is that? 20 plus 0.2, 33.013 over here, okay? And 44 t over 100 minus 1 minus t over 300 and 7 dt and minus 0.7 times 33.013, okay? That's the number of people at time t equals to 33, okay? Now put this number in there, we're gonna check it out. Here, we can calculate the 20 plus integral of here. I'm going to use a copy of this, okay? Or up to t from here. But this time t is what is at 33.013, okay? 013, this one, and the finally minus 0.7 and times 33.013. Are you okay with this?
Yeah.
So when you take it over here, there are what? 3.803 people there. Okay? At time t is here. .803 people. This was a compare these two, right? Maybe you can show this graph right under your answer set. Okay? So this is the minimum value, right? Absolute minimum over here, okay? So at time t equals 0, you can write that at time 33.03, there was a minimum number of people. Okay? Which is what? 33.803, okay? People. Okay, that's the answer, okay? This one is a little more work. Okay? Just try first AB or one more ABC. Okay? Are you okay with this? So number D, this one is a lot of work, right? When you take it over here, probably we have a lot of work there, okay? We need to make a graph, take a derivative, find out what minimum value of this one. Okay, put this one in the calculator again, find out the number of people, right? At this time. Are you okay with this? Now this one needs a little more work, okay? Yeah, number D, yeah, a little hard. But ABC will be okay. All right, so just try to figure out the value one more time, okay? All right, that is number 2. So calculate section is a lot of work. Okay.
Okay.
Particle moves along the x-axis with velocity given by the equation that way, and the particle is positioned at x equals 5. Okay, when x equals 0, particle, where is it? Negative 5 there. Particle move right to the left. Okay,
Yeah.
at this is the position is what? At this location at x5, particle move over here. Okay. Now we're gonna move right. From here, velocity is positive, move to the right. Velocity is negative, move to the left. Okay. Now let's find its acceleration of particle at time t equals 0. Acceleration is what? Take derivative of velocity. Okay. Velocity derivative. That's acceleration, right? Okay. So 10 sine 0.4 point t squared or t squared minus t plus 3. We take a derivative. Is it okay?
Yeah.
Okay, wow, this is a lot of work anyway. But we can use a calculator, right? So you have some function to take a derivative of this one.
Yeah.
Let me show you. They have derivative here. Let me check out. If you have like TI-89 or they have function to take a derivative, okay?
Okay.
dx/dt, right?
Yeah.
Very derivative. Where are you going? Oh, over here. Take a derivative, this, okay? Take a derivative. I put this number in there, okay? So 10 sine 0.4 and t squared is squared. And over t squared. And minus t and plus 3, okay? That equals to 0. That's correct. It can be 0. It should be in terms of t. Or number equals? Or equals? No, doesn't work. Okay, we take a derivative, okay? I don't know how to use this, okay? dx, oh, I'm sorry, this is the x over here, right? This is dt, okay? That's why I didn't get the dt. Okay. Equals? No way. Still not working. dt over d, t squared over d. And the slider t, what that means? Over here, add the slide t, okay? Over here, t equals, what is that? That's, over here, right? After that, we take t equals to 3 over here, okay? Not this one,
Yeah.
okay? So how can we find that? I'm gonna try it one more time, okay? Oh, I lost again. When t equals 3, how can you express this one? T equals 1. how to use this one, okay? Just before I got the number here, t equals 3. T equals 3, something like this. Oh, this is not working. I don't know how to put it the way t equal the number t there, okay? This is t, but they use right t is 1 there. I'm gonna change. How can I change this one? Okay, let's try one more this one. Oh, over here. T equals 3. Okay, oh, I don't know why I have this one. Okay, t equals 3 over here, right? This derivative, okay? You have to use a calculator, okay? Take a derivative at x equals 3, isn't it? Are you okay with this? At x equals 3, that is what? Negative 2.118. Okay? You know how to use a calculator, right?
Yeah.
Take a derivative and put this number x equals 3 there, okay? You got the answer over here. So negative 2.118, okay? Negative 2.118. There's no unit. Okay, there is no unit there, okay? All right. This one from here, x equals t equals 3, okay? You got this number. That's fine. Okay, find position of particle at time t equals 3. Position is what is that? Acceleration first one is at time t equals 0, that is at negative 5, okay? So at position x equals 3 is how much? X equals 0. From here, we can add over there, okay? Velocity of this one, 0 to 3, still 10 sine 0.4 point t square over t square minus 5 minus t and the plus t, right? That is x3, okay? This is a fundamental theorem of calculus. Are you okay with this? We did already this one, right? Do you remember this one? xb equals what? F over a. We count from here. You're gonna take all integral is what? X prime t, okay? This is a fundamental theorem of calculus, okay?
Yeah.
FTC. So we have to use a calculator, okay? Yeah, it will be no problem at all. With this number, I'm gonna move this, okay? x3 equals now x0. x0 is what? X equals negative 5, okay? This is negative 5. So negative 5 plus some of their change in velocity, right? I'm gonna write integral over here. I'm gonna borrow this integral. Integral 0 to 0 to 3, okay? 0 to this number up to 3. And this function, okay? I'm gonna take this one. And dt is okay. That's it. But there's no number. 0 to 3, negative 5. I don't know what happened. Why need Francis over there? Before that, Francis. Okay, put this number, Francis. There's no number. You have a calculator.
I do.
Can you try to find this number using your calculator? I don't know what happened, what's wrong with this, okay? Nothing wrong, but I don't get any number there. You cannot use t as an integration variable because it's already defined. Oh, we're gonna use different, we use x here, we're gonna use x, okay? I'm gonna use the x there.
Okay.
Because we use the same variable, okay? X. I'm going this one, okay? Change the x. This decimal is weird. And another x. X. But we still don't get the number over here. You can use t as an integration variable because it's already defined. Oh, that's it, not dx. Okay, now this is that. Okay, so the value we are negative 1.760, okay? Negative 1.760. Okay, that is f over x over 3, okay? The position at time equal 3. Is it okay?
Yeah.
So number A, number B will be okay, right? Just use okay calculator, okay? Yeah, the next one is 0 to 1.5 BT. We're gonna check this one. So 0 to 1.5 BT. BT is what over here. 10 sine 0.4 t square and t square minus t and plus 3, okay, dt. Now check out this one.
Yeah.
Just so I 0.3.5, okay, this is the BT of you. We take calculate this one. It's okay. From 0 to 3.5, this is 3.5. So, okay, so change right velocity between 0 and 35, okay? Change in position, right? That is how much? 2.844, okay? 2.844. This value, okay, change in, right? The integral of 0 to 35 will change in positions between 0 and 30.5, okay? That equals to 2 point, I just said 2.844, I said, okay? Yeah, 2.844. What about this one? That is travel distance, okay? That is travel distance, this is a position. This is travel distance is different. Travel distance, we're gonna check it out. To the right distance, to the left distance, you're gonna add more, right? So that's why we're gonna make a graph of BT over here, okay? So you check it out, graph of BT. This is the BT graph. Curve, and put this is the Y course. That's the graph. Wow, that's it. Zero to 3, that's 2 bucks. This was a negative 5, 2, 5. That is negative 10 to positive. That's enough, right? Where's the graph? Negative 10 to positive 9. Positive 10. Okay, that's the graph. It's okay.
Yeah.
But from 1 to 3.5, I'm gonna cut up the range over here, okay? X equals 0 to 3.5. Cut up over here, okay? Over here, 3.5 over here, right? But up to here, that is what? Up to time 2.802, that is a positive slope. I'm sorry, positive velocity, right? Move to the right. After this, to the right, okay, 3.5, that is move to the left, okay? That is also distance. When you make, right, the area is a negative number, but we're gonna make it positive, right? Travel distance must be positive number, okay? So we're gonna calculate again over here, okay? I'm gonna make a graph, just give me 1 minute. This is a graph. The graph looks like this way. From there over here, move to the right. At this point, 2.802, 2.802, that's correct, let me check. 2.02, after this, 3.5, move to the left. This is a positive, this is move to the left. So we find out all travel distance, okay, add more, okay? Okay, that's fine. So the travel, this one equals how much? 0 to 3.5, okay? So this one, the BT, DT, that is a positive, okay? So, no, not 3.5, 2.802, okay? 2.082. After 2.082 to the what? 3.5, so it's gonna be negative number, right? Because the BT is negative. So you're gonna make a positive. Is okay? Yeah, that is sum of our travel distance. Okay? Now let's find this one. Oh, this was a lot of work, right? Integral again. I'm gonna, this with the same thing, okay? Integral again. I can use this one, okay? 0 point, this one is how much? 2.082, okay? 2.082. Okay, this one is travel distance to the right, 2.560, okay? And this plus, so you have to turn integral, okay? Or you can make a separate and add more later, okay? I'm gonna do integral, okay? So for this integral is the same side. But this time, this one is now 2.082, 2.082, and height is what the last time is 3.5, okay?
Yeah.
Okay, anyway, sum of this one is how much is that? 2 point 2.802, 3.5.
Yeah.
Just before 2.88, but this is getting small. Something like that. Let me check one more time. 2.08 to 3.5, then nothing different. Let me see. I'm gonna take this on the other side, okay? 2 point, oh, very small, right? That's why, okay, I got it. So anyway, when you take them out, okay? Yeah, this one is very small, 2 point, just before 8, 4, this is very small. Okay, when you take them out, this one, got this one, right? 2.56, another 2.83, right? Yeah, okay.
Yeah.
So total, I'm gonna add this one, okay? But this one should be negative number. This is positive number. That is negative velocity. It can be, this one, it can be positive here. I prove here, absolute value? No, right?
Yeah.
Okay. Something wrong. This is negative, right? The area of this one should be negative number, but this is just still positive.
Yeah.
I don't know what happened. Okay, forget this. This is the graph over here. Velocity is negative. This move to the left. The area of this one is a negative number, but still this is a positive number. I don't get it, this one. .082 up to 3.5. Let me see.
Yeah.
2.082 up to 3.5. That's correct. This is a negative velocity. It's going to have a negative number, but this is still positive number. I really don't understand. But anyway, this is the absolute value. That's why. But without that value, still it has a positive number. That's impossible. Okay? Yeah, that's impossible. This one is about the travel distance to the right. This is travel distance to the left. You're gonna add these two. But this one should be negative number, but it's a positive number. Okay. Evaluate, right? Yeah, evaluate this one, both. The meaning is what? This is displacement, right? Displacement means what? Position.
Yeah.
Okay? Position. Where is this particle? But this was travel distance. It's okay? This one is the travel distance, or total travel distance. Okay?
Yeah.
But this is okay. Travel distance, a little trouble. Okay, trouble. Let me check one more times. 2.802.3.5. When you add this one, okay, 2.7. Okay, let me check this number here, okay? I don't know what happens. So we don't get this number, okay? All right, number D there. A second particle moves along the x-axis with position given by x2t. This is x1, right? First, okay? Second 2 is what the position is given by the equation here. T squared minus t, but still this is what t equals same interval, okay? 3.5. At what time t are two particles moving with the same velocity?
Yeah.
Okay, we're gonna find the same velocity, right? Now take a derivative over here, right? x2 prime t, that's the velocity of particle 2, right? So 2t minus 1. Are you okay with this? So now let's find out, right, in intersection of these two graphs. First one is velocity 1. I'm going to put this 1 over here. This one is 10 sine 0.4 t squared over t squared minus t plus 3 That the BT is what this one, okay? This is the BT, right? Must be equals what? 2t minus 1, isn't it? We're gonna find the intersection of these two graphs. This is the y1 graph. This is the y2 graph, okay? Now, draw the graph over here. Now this is out. First one is y1, still y equals 2t minus 1, 2x minus 1, because we gotta use t, right? 2x minus 1, at least this one. Second one is y equals over here, 10 sine t, right? We already over here, this one. Okay, this is the second. This is it, right? We have 2. Yeah, where the intersection over here? This point. Okay, at this point, 1.571, they have the same velocity, right? Can you see it over here?
Yeah.
1.571, they have the same velocity, okay? So, that's this. T equals 1.571, okay?
Yeah.
Okay, that is the number D. I'm gonna make sure, okay, one more time the graph of this one. Y equals 10 sine 0.4. Can I use the t square? Okay, just give me one more t square. T. Not too much. This is the graph. Zero point 2.82, that is positive. 2.80. Oh, I'm sorry, 2.802, right? That's why you got my different answer. 2.802. That's why 3.29. 2.80. Oh my god, this is impossible. That is a negative number, right? That's fine, okay? But we make travel distance to make a positive, okay? So we're gonna put over here absolute value, okay? So I'm gonna use this one plus over here and the absolute value over here and copy this one, okay, inside absolute value.
Yeah.
Okay, 3.737, right? 3.737 travel distance, okay? Total travel distance is 3.737. This one.
Yeah.
Total distance, right? 3.737, okay? Now we got all the answer over here, okay? Oh, sorry about that. This is impossible.
Yes.
2.802. Okay, yeah, total distance anyway, 3.737, okay? But this one is travel distance, okay? That interpret right. Travel distance, this is placement, okay? Where is the particle over here? The particle is now probably 0 around over here, 2.844 there, okay? Particle is up here. But this means what travel to the right is just before to the right is how much? We just got this number, this much, okay? 2.7, something like that, okay?
Yeah.
Go back, okay, 1 point, okay? To the right, 3.291, okay? 3.291. Travel to the right, travel distance is 3.291. And to the left is what? 0. Just make a positive, right?
Yeah.
0.447, okay? 0.447, okay? But left, but still travel distance make a positive, right? Sum of these two equals what? 3.723, okay? That is travel distance. That means travel distance. Okay, that difference, okay? So position means what we say, you can say displacement of particle, okay? That represent, okay, a displacement of the particle. Is it okay?
Yeah.
All right. So now we continue non-calculated section over here, okay?
Yeah.
Okay. Now let's try this number 3 there. The graph of continuous function z, the derivative function f, okay, is shown over here. Okay. So g equals actually f prime equals g, okay? G is what? Derivative of f. The function g is piecewise functions. You can see the piecewise function there, okay? 1, 2, 3, 4, 5 lines, and another one is a curve, okay? And the g of x equals 2 minus 3 to 6 over here. 3 to 6, this one equals to, graph is y equals 2 times x minus 4 square, okay? If f is 1, what is the value of f over 5? Okay? What is f over 5? This is the graph of g. F is what? Kind of what? Original function, right? Antiderivative. Using fundamental theorem of calculus again. Okay? F of 1, that equals how much? From f of negative 5, we're going to take, right, or integral from negative 5 to 1, right? F prime x, isn't it? That's the fundamental theorem of calculus. But f of negative 5 is, we don't know, but f of 1 is 3. So 3 equals f of negative 5 and plus negative 5 to 1. F prime x is gx, okay? That is derivative of gx dx. So we're going to find the value of this one. How can you find the value of this one? Integral negative 5 to 1 up to here, you're going to find the area of this one, right? Oh, check it out. What is the area of here? Here is 3, and down is 3. 3 times 3 is 9. This area is 9. Are you okay with this?
Yeah.
So this is 1 times 3 divided by 3 is what? Negative 1.5, right? 3 over 2 is 1.5, isn't it? That is a negative area. Still, this is negative, right? This is now positive. 1 times 2 divided by 2 is 1, okay? This is 1. Up to here, right? That's it. Sum of this one, how much? This one is actually equals to negative 9 minus 1.5 and plus 1. 10.5, negative 10.5 plus 1 is what? Negative 9.5. It's okay?
Yeah.
So 3 equals, the equation this one. 3 equals f of negative 5 plus minus 9.5. So f of negative 5 is how much? 3 plus 9.5, okay? From here, f of negative 5 equals 12.5, okay? Are you okay with this?
Yeah.
Yeah, that's the answer, okay? The next one, evaluate v over here, integral from 1 to 6 gx. This is already gx, right? Take integral, right? From 1 to 6. I'm going to delete this one. From 1 to 6. We start from here now. 1, 2, 6 over here. Area of this one, right? So up to 1, 2, 3 is how much? This we can use this rectangle, right? 2 times 2 and 2 times 2 is 4, right? That equals to what? 4. Up to 3 over here. But 3 to 6, we're going to follow this one, okay? 3 to 6 equals to how much? This is the graph is given. 2 times x minus 4 square dx. Are you okay with this?
Yeah.
So you're going to find this one. 4 plus, what is the entity with this one? Plus 1 is 3, and divided by 3. We still have 2 there. 2 over 3, x minus 4, and the cube. It's okay?
Yeah.
Take this integral. Okay, you can use constant out. Integral from 0 to 6. Okay? So 4 plus 2/3. Inside the parentheses, what is that? Put this number 3 there. 3 minus 4 is a negative 1. Cube is a negative 1. I'm sorry, 6 first. Okay, 6 minus 4 is 2, right? 2 cube is 8. And minus this is what? Negative 1. Another negative 1 over here, okay? So inside is 3, it's okay. So 4 plus this is 3, 9, it's okay. So 2/3 times 9 is 6. So 4 plus 6 is what? 10. That is the value of this one, okay? You can write down answer 10 over here. I think number choice A and B will be okay, right? All right. The next one, number C there. X is between negative 5 and 6. Okay, negative 5 here all the way down, okay? So if any is the graph of both increasing and the concave up there, F is what? The value of F increasing?
Yeah.
Increasing by its derivative, right? F prime is gx is what? Positive, right? That is increasing, isn't it? F is what? Concave up. Concave up, what is that? Second derivative, right? G prime is the second derivative, it's okay? Must be positive, right?
Yeah.
Okay? So concave is F second prime. Second prime X is what? First prime G of X. This is first prime Fx is what? G of X, okay? Using this, we're gonna check it out. For this graph is first, where is it increasing? I'm going to take increasing. Where is it increasing? Only here it's increasing. Here it's increasing, right? Positive. On this case, right, its slope is what is that? Second derivative is positive. Where is the second derivative positive? Slope of this g of x is second derivative. That slope is positive, right? In here, both are increasing concave up, right? Slope is that is the second prime x is positive. Is okay? So this one is still positive, the slope is negative, concave down. From here is what? Increasing slope is positive again. So up to here, they are always what? Increasing and concave up, right?
Yeah.
So it's gonna be 0 to 1 first. Okay? 0 to 1 positive, and slope of this line is positive, that is concave up, right? So 0 and x, 0 and 1, okay? Another one over there, right there, 4 to 6. Okay, the graph is what? Increasing in this section, that is a positive, increasing slope of this line is the second derivative, concave up, right?
Yeah.
That means what? G prime x, okay? Concave up, same things. Because F prime is G, okay? F second, this means what? F second prime is what? Equals to G prime, okay? But number C is okay too, I think. Right?
Yeah.
Okay. Number D, find x coordinate of each point of inflection point graph of. Inflection point is by f prime x equals 0, right? F prime x equals 0 on this graph, what is it? G prime x equals 0, isn't it? Where is G prime x equals 0? Here.
Be around, yeah, one change.
Here. But check it out. Here is what is the slope of this one is positive concave up here, right?
Yeah.
Slope is positive, this times concave up. But this one is what? Zero. There's no concavity, right? So this is not inflection point. Forget about this one, okay? Inflection point is what? The right, the left, the right, opposite side both what change their concavity, okay? Concave up, the next concave down, right? That is inflection point. This is nothing. Okay? So this is nothing, this is nothing. Oh, what about over here? After before this graph, slope of this one is negative, that is a concave down, right? Right at this point, that is a concave up, isn't it? Because slope of this line is a positive. So at x equals 4, there is what? Inflection point. Are you okay?
Yeah.
So at x equals 4, there is inflection point. The reason is what? You can explain this one, okay? Before 4, slope of this line is negative. That is a concave down. Okay? It's okay.
Yeah.
So when x equals less than 4, you can explain, okay, when x equals less than 4, slope of the line negative. That means what? Concave down. After greater than negative or positive, I'm sorry, positive 4, right? Plus 4, positive 4, okay? Not negative. Slope of gx is positive. That means what? Concave up. They change concavity, right?
Yeah.
So at x equals 3, there is inflection point, okay? At x equals, so therefore, at x equals 4, there is a point of inflection. Okay? All right, so we just finished, okay, number 1, 2, 3 today. Okay? Just try to figure out this one more time, okay, after class, okay? Okay, if you have questions, you can email to me, okay?
Okay.
All right, so now let's finish our lesson today, okay? Okay. I'll send it out, okay, the video link, okay, right after this class, okay?
Okay, sounds good. Thank you.
Okay, you're welcome. You have a good night, okay?
Okay. Have a good night, Chung.
Okay,
Bye.
bye.
Thank you.